Welcome children to the virtual chemistry class. In the last video we have discussed about significance of formula and we have learned about molecular formula of a compound in the last video, how to write molecular formula and what are the significance of this molecular formula. In the last video we have discussed, and also the empirical formula of a particular compound. Today our topic is chemical equations. A chemical change which involves the transformations of one or more substances into new substances is called a chemical reaction. So chemical reaction is just a process for transformations of products to a new products. The substances which react together are known as reactants, and that new substances that are formed after the reaction are known as products. The symbolic representations of chemical reactions is known as chemical equation. Definitions of this chemical equation is the representations of chemical reaction by using symbols and formula of the substances involved in the reaction is known as chemical equations. Now, in the chemical reactions, two parts are there. Left hand side. In this left hand side, the reacting species are written, and in the right hand side, the new substances that are formed are written. For example, when coal is burnt in air, here the main ingredients coal is an allotrope of carbon and air contain oxygen, a new substance carbon dioxide is formed. Carbon, it is solid in nature, oxygen gas, carbon dioxide in gaseous states. So that means our word equation becomes carbon plus oxygen gives you carbon dioxide, and the chemical equations, the symbolic representations of these word equation will be C plus O2 gives you CO2. Now C for carbon, O2 for oxygen molecule gives you CO2. That means the carbon dioxide. So in this case carbon and oxygen are the reactant. Since they are reacting, these carbon and oxygens are reactant and carbon dioxide are the products because this is formed after the reactions and it is written on the right hand side. So if something is written on the left hand side, it will be termed as reactants, and anything that will be written on the right hand side except energy will be termed as a product. Sometimes in few chemical reactions heat is mentioned, but this is not the reactant, neither it will be the product. This is the change of energy during the chemical reactions. Now we'll learn how to write chemical reactions. There are certain rules for writing the chemical equations. Names and formula of all the reactants and products should be known. And you know how to write the molecular formula of the reactants and the products by knowing the valency, and after doing criss-cross method, what we have discussed in the last videos. Symbols of the reactant should be written on the left hand side with plus sign. Plus means this plus sign signifies that they are reacting to produce products. Symbols of the products should be written on the right hand side with plus sign. If more than one products formed, it should be written with plus sign, but here on the product side it never signifies that the products will react. So these plus signs on the product side will signify only that there are more than one compounds formed, but the plus sign on the reactant sides, that is on the left hand side, will signify only that reactants are reacting. Reactants an arrow should be given like this. This is the arrow between the reactants and products if it is not reversible reactions. After some time we will discuss about reversible reactions. Reactants and the products are represented in their molecular form and not their atomic form. Should not write in the atomic form. For example, when carbon and oxygen, the previous page what we have discussed, in the carbon and oxygen you can't write only O, because O is the symbol of oxygen but O2 is the molecular form of oxygen. Look at this carefully. Carbon, C is the symbol of carbon as well as the molecular form of carbon. Similarly, sodium, Na will be the symbol of sodium as well as molecular formula of sodium. You have to mention always in the molecular form, not in the atomic form. Now oxygen, O2 is the molecular form, C is the molecular form of carbon also as well as a symbol, but O2 is not the symbol of oxygen. O is the symbol of oxygen. You should not write only O, you should mention O2, that is in the molecular form. Now the reaction to show the formations of hydrogen and oxygen cannot be written like H plus O to give H2. Why? Because H is an atom, O is an atom, and there is no independent existence of this atom. What we have learned in the definitions of this atom, atoms are the smallest particles of element which don't have any independent existence. They are highly reactive in nature. They will always found in the combined state except for case of the few metals. Reactants and the products are represented in their molecular form, not their atomic form, because this is very important, because molecules have independent existence while atoms don't have any independent existence. So the correct representations of these reactions for formations of water from hydrogen and oxygen will be H2 plus O2 gives you H2O. For example, when zinc, some more examples are there. When zinc oxide reacts with carbon, zinc and carbon monoxides are formed. Now zinc is the molecular state Zn, since it is a metal. Carbon monoxide CO, zinc oxide ZnO, carbon C. Now zinc oxide plus carbon gives zinc plus carbon monoxide. This one will be your word equation, and ZnO plus C plus gives you Zn plus CO will be your chemical equation. This S signify the solid state, that G in the parenthesis will signify that this carbon monoxide is in the gaseous states. So in similar line, you can write the reactions of hydrogen and chlorine to combine hydrogen chloride as H2G, because it is in the gaseous states. Cl2G gives you HCl, but this is not balanced. Now magnesium burns completely in air to form magnesium oxides. Mg plus O2 gives you MgO. Now what just I have told that this is not balanced case, because here is 2 atoms of hydrogen present, 2 atoms of chlorine present, but here only 1 atom of hydrogen, 1 atom of chlorine present. So that's why you have to balance these equations. So now we'll learn how to balance the chemical equations. Before balancing the chemical equations, we should know that why you have to balance the chemical equations. Because as per law of conservation of mass, as the name suggests, that conservations of mass, that means mass can neither be created nor be destroyed. That means if you don't balance this equation, that means you have already destroyed 1 atom of hydrogen, because here only 1 atom of hydrogen is there. 2 chlorine atom initially present, here only 1 chlorine atom present. That means you have already destroyed 1 chlorine atom. You can't do this. That's why you have to balance that chemical equation. The total mass of the elements of the reactant side should be equal to the total mass of the elements on the product side, as per the law of conservation of mass. This can happen only if the number of atoms of each elements of the reactants is equal to the number of atoms of corresponding elements in the products. And this process is known as balancing the chemical equations. Now look at this, H2 plus O2, that means two hydrogen atom, two oxygen atom combine to form one molecules of water, H2O. Here only one oxygen atom is present, but in the reactant side two oxygen atoms are present. That means if you left the equations at this stage, that means you have already destroyed one atom, but you can't destroy an atom. Though atom don't have any independent existence, but you can't destroy an atom. In the above equation, there are two atoms of hydrogen and two atoms of oxygen, and this unbalanced equations is known as skeletal equation. Hydrogen plus oxygen gives you water. This is your word equations, and this is your skeletal equations. Unbalanced equations is skeletal equations. Now this equation does not fulfill the law of conservation of mass, which states that total mass remains unchanged during the reactions. Now there are several steps to write balanced chemical equations. You should follow that steps. First step, you have to write the skeletal equations from the word equations. For example, when nitrogen and hydrogen reacts with each other, ammonia gas is formed. This is the reaction. This is the observation. And you have to narrate these observations like this way. Nitrogen plus hydrogen gives you ammonia. That will becomes your word equations. Now you have to write the skeletal equations. The first step, nitrogen. You should mention all the things in your molecular form, as we have already discussed that fact. That molecules has only the independent existence but not that atom. So nitrogen N2, hydrogen H2, ammonia NH3. First step, count the numbers of atoms of each elements on the either sides of the arrow. So nitrogen here 2 atoms, hydrogen here 2 atoms, here nitrogen 1 atom and hydrogen 3 atoms are present. We can see that there is an extra atoms of nitrogen present on the reactant side. Next step, first multiply the products by 2. If you multiply with 2, so now nitrogen atoms becomes 2, here nitrogen atom becomes 2, that means nitrogen becomes equal. Now hydrogen remains as 2 as in the left hand side, and here 6 atoms of hydrogens are present. Multiply the hydrogen molecules on the reactant side by 3. After multiplying 3, it will become 6 hydrogen atom, because 3 into 2 gives you 6 and 2 into 3 gives you 6. Now 3H2 means 3 molecules of hydrogen. 3 molecules of hydrogen. 3H2 means 3 molecules of hydrogen. 1 molecules of hydrogen contains 2 hydrogen atoms. That means 3 molecules of hydrogen will contain 3 into 2, 6 atoms of hydrogen. For example, H2 contains 2 hydrogen atoms. So that means 3H2 of course contain 3 into 2 hydrogen atom, that is 6 hydrogen atoms. Now N2 contains 2 nitrogen atoms, and 2 NH3, since it contains 2N, contains 2 into 1, because in NH3 1 nitrogen atom is present, nitrogen atoms, 2 nitrogen atoms are present. Another examples, the water breaks down into hydrogen and oxygen. When an electric current is passed through it, the word equations will becomes that water arrow a hydrogen plus oxygen, and the skeletal equations H2O gives you H2 plus O2. In a similar step, count the number of atoms on the both side. Here two hydrogen atoms are present, two hydrogen atom and two oxygen atom, but here only one oxygen atom is present. Step 2, multiply left hand side by 2 to equalize this oxygen. Look at this, beforehand it was becomes the one oxygen atom. So if we multiply the 2, so oxygen atoms becomes 2. So balancing of oxygen completed. Now you have to balance that hydrogen atom, because here 4 hydrogen atoms are present, here 2 hydrogen atoms are present. So just to balance this hydrogen atom, multiply that hydrogen molecules with 2. Now some more examples of this you can try in your home, that Mg plus O2 gives you MgO. It will become 2 because here 2 oxygen atom. To balance this 2 oxygen atom, multiply the 2. Informations provided by balanced chemical equations. Students, remember that I will give you the link for balancing that chemical equation step by step for harder chemical equations in the descriptions box. You can follow the links given on your description box to learn more about that how to balance that chemical equations. What are the informations provided by that balanced chemical equations? The first, it will tell us about the reactants and the products, their symbols and the formula which are involved in the chemical reactions. It also tells us about the numbers of atoms of each element involved in the chemical reactions. It also proves the total mass of substances on the both sides of chemical equations are same, because the law of conservation of mass, number of atoms, you know that how to count the number of atoms, as well as for balancing the number of atoms you have to know the balanced chemical equations. Now what are the limitations of these chemical equations? First, a chemical equations does not tell us about the physical state. If you forgot to write that S, G, L, AQ, then that equations will not give you the correct informations regarding the physical state of the substances. But to make it more informative, you have to mention that S for solid, L for liquid, G for gas, AQ for aqueous solutions. If you dissolve a particular substance in water and form a clear solutions, then it will be termed as aqueous solutions. And to mention that aqueous solutions, you have to write AQ. The reactions may or may not be complete. Remember, some reactions may not complete throughout our lifetime. For example, nuclear reactions. But the balanced nuclear reactions will never tells you about that it will completed or not completed. And equations does not give any information regarding the speed of reactions. This is more important fact. The speed of reactions means what? The amount of reactant reacting at a fixed time interval will be termed as speed of reactions. This term, speed of reactions, signifies only about that amount of reactant reacting under a specific time span. An equation does not tell us about the concentrations of the substances. Concentrations means, actually, in simplest language, concentrations means the amount of substances in a fixed volume, only in simple senses. In some equations, terms such as diluted or concentrated may be added. This diluted means more and more solvent are already added to make it faint, and concentrated means, you understand the term that concentrated means the more and more amounts are present. An equation does not show about the conditions such as temperature, pressures and the catalyst. If you forgot to write this catalyst like this, the temperature, it will never show you that exact scenario of these conditions required for this case. In this case, 2SO2 plus O2 gives you 2SO3 sulfur dioxide. When combined with oxygen in open air, it will form sulfur trioxide, but these reactions is very slow in nature. That's why platinum catalyst is required, and elevated temperature 450 degree to 500 degree centigrade is required. But if you forget to write this one, you never know about the conditions of these reactions. In similar line, for the case of that photosynthesis, if you forgot to write the sunlight and chlorophyll, it looks like a very simple carbon dioxide reacts with water to produce the glucose. But you have to mention that sunlight and the chlorophyll, this is the necessary conditions. But you have to mention it separately in the chemical equations. It never gives you any information unless you have mentioned about the color changes. Lead dioxide, chocolate brown, when heated it will form lead oxide, which is yellow in nature. What previously we have discussed about that during the writing of that arrow, we have mentioned the term that reversible reactions. And equations does not tell whether the reactions is irreversible, reversible or not. Reversible reactions are generally represented by both-sided half-headed arrow or fish hook arrow. Look at this arrow, it is different from this arrow. This is both-sided, both-headed fish hook arrow. The significance of this arrow is that when iron is react with water to gives you ferrosulfuric oxide Fe3O4 and hydrogen gas is formed, and further if ferrosulfuric oxide reacts in suitable conditions with hydrogen, it will gives back that iron and water. This is the reversible reactions. If you forgot to write, if anything, any literature forgot to write that this reversible sign, these reactions will never tells you about that reversibility of this reaction. So this is another drawback of these chemical equations. So we came at the end of this chapter. Now check your progress. The chemical equations is not balanced. What will be the balanced chemical equations? Please try in your home to balance these equations one by one. In the descriptions box there is a link for more information regarding the balancing of chemical equations. Just click on this link and you will get more advanced informations regarding balancing chemical equations. So in the next video we'll try to solve that MCQs and other fill in the blanks. Till then, stay safe.